So in this video I'm going to discuss Codeforces round 942 rated for Division 2. So I will be solving first 4 problems in this problem set. So let's start with problem A, that is contest proposal. So in this question I will be given total n problems and the ith problem has an expected difficulty of at most b of I. Okay, and we are given that the difficulty of AI problem is a of I. This is expected and this is the current difficulty. Okay, and what we can perform on this array is like that we can choose any integer w and insert that into array A and sort the array in the non-decreasing order and remove the last element from it. In another terms, what question is asking you to do, you can simply select any integer w and what you can do, you can simply remove the largest element in the array A. And after this operation, you have to satisfy one condition, that your all of the a of I should be smaller than or equal to b of I. And what is the number of steps possible? What is the minimum number of operation you can perform such that this condition is satisfied after this operation? Okay. So I think so this question is pretty much brute force only because constants are pretty much and very low. If there is any another way to solve that question very much quickly, you can comment the question answer in the comments. And till then I will show the easiest part, that is the brute force solution. So what I am doing, I'm simply running this loop while this condition is not satisfied. And after that, what I'm doing, I'm simply pushing the W. Okay, they have said that I have to push a W in my array A and that I choosing the minimum as possible because it will help me in this condition later. Okay, so I will simply pushing one in my array and sorting it and simply removing the last element of my array, that is the largest one, and simply increasing the count and then printing the count. So that's how you can solve the problem number A. So let's now discuss the problem number B, that is coin game. So this question was pretty much interesting, I would say. So let me tell you here what question is asking you to do. Simply you are on a round table. And on the round table there are some number of coins. Like this is a I will tell you what this denotes. Like U, D, U, and D. And each of the number depend each of these character denotes that whether your coin is flipped or unflipped. U means the coin is placed upper side, and D means the coin is facing downside. And in one operation, what allies can do, there are two players, allies and Bob, and they will play alternatively. So each player in a single operation, what can do, he can select a single character and remove the character from the list and simply flip the neighbor and flip the neighbor's coin. For example, if it is down, it will make it upper, and if it is down, it will make it upper. And next is Bob's turn. So let's suppose Bob chooses this U, and what he will do? He will simply erase that part and make this U as D. And what is the neighbor? This is already moved. Its neighbor is this U, and make it equal to D. Okay, and that's how you can perform the operation. And you have to tell them what is the you can tell them if allies wins and how the allies wins. Allies can only wins if the last operation was moved by allies. And what is the last operation? Last operation would be that operation in which after that operation none of your coin is facing upwards, which means you cannot perform any operation. If at any state you cannot perform any operation, you would lose. Okay, which means I have to tell them but which player moves the last operation. So if the allies move the last operation, then allies would win. If Bob moves the last operation, then Bob would win. Bob would win. So if allies wins, you have to print yes. If Bob wins, you have to print no. Okay. So let me see the constants of the question. The constants of the question are very very low. Okay. You can brute force this also. So let me tell you how you can brute force this also. Simply, I have make a function. Like if my none of the character in my S is equal to U, then I will simply print 0. Okay, then I will simply print u 0, which means I cannot perform any further operation, which means my current user loses the game. If your any of the number is equal to 0, which means you can perform operation and simply return 1. Okay, and what I'm doing here, I'm simply iterating a loop while this condition is true. While this condition is true, I'm simply iterating a loop from 1 to n and targeting the first u. Okay, targeting the first u. If I'm encountering a u, I'm what I'm doing, I'm simply changing the its neighbor. If my neighbor, if my neighbor is u, I will make it equal to d. If my neighbor is d, I will make it equal to u. Okay, you can also check the last and first index cases separately. That's how what I've done here. Okay, now you can target that u which you have found. Okay, so what I have done here. For example, if I am founding a u at index I am storing in index. Okay, and flipping its neighbor. Okay. After that I'm simply removing that index from a S. Okay, that's a performing the operation. And you can know as costs are very much low, you can perform this operation you can perform this operation n square and n cube time also, because n is only 100. So it will definitely work. But there's also a smaller solution, smaller part of this solution also. That is that if your number of views are equal to odd, then Alice would win. If your number of Bobs are even, then Bob will win. So tell me, how is this possible? Like, this is my solution. You can comment it down. How is this logic working? If you get to know about this, you can comment the solution. You can comment in the comment section. Okay. So that's we can solve the problem number C. So let's now discuss the problem that's we can problem B. So let's now discuss problem number C, this permutation counting. So it is very much good problem. I would say that I have also gotten the wrong information in this also. So let me tell you the question here. You are given total number of n numbers. You are given total number of n numbers like 1, 2, 3. Oh, let me take the here example only. For example, you are total given a n numbers like this. I'm taking this test case. Okay, okay. Wait, let's okay. So what each of the number represents? My each number represents that you are. For example, let's suppose you have some number of coins. In this question, let talk in terms of coins. Okay, or IDs. Let me talk in terms of coins or cards. But it is using like cards. Okay, so let talk in the terms of cards. So what this array represents? This array represent your total. Your array represent that if it is the first index. Yes, it is the first index, which means you are total having 7 cards of index 1 of number 1. I would say you are total having 7 cards of number 1, 6 cards of number 2, 1 card of number 3, and 7 cards of number 4, and similarly continue as on. Okay, and you are also having a number 7, and using that number 7 you can exchange and you can take any card of any number. For example, if I am having number 7, I can also take a number 1 number card of number 1 and decrease it to 6. I can make decrease it to 6 and take a number card of 2. I can decrease it to 5 and take a card of 3 also. So that is the operation which you can perform. Okay, right. So hope so that the value of number k is also clear to you, but why k is given to you. Okay, now move back to the question. What question is asking you to do? So after choosing this k, after utilizing this k, you have to rearrange the cards in some order. Okay, so let's suppose I'm rearranging the cards. Let's suppose in this order: 3, 5, 6, 7. Okay, after rearranging the cards in some order, this is the smaller part of this part of this array. So after rearranging the cards in some order, you have to tell them how many sub-arrays are beautiful. What are they using? Wonderful or whatever let me take beautiful only. You have to tell them how many sub-arrays are beautiful and what is the definition of beautiful sub-array. The definition of beautiful sub-array is like that your sub-array must be of size n, that is n given to you here. Your sub-array must be of size n, and it should be performing a permutation from 1 to n. It should be performing a permutation from 1 to n. So that is the operation you have to perform, right? Hope so it is clear to you. Okay, right? Hope so it is clear to you. Let me repeat it once. So each number represents that you are total having a of I cards of a of I number, which means okay, which means in this case you are total having 7 cards of number 1, 2 cards, 6 cards of number 2, 3 1 card of number 3, 7 cards of number 4, and you can utilize this k, in this case k7. You can utilize this k to buy any card of any number. Okay, which means you can total buy 7 cards of any numbers. After that, buying 7 cards of any numbers, you have to arrange these cards in some order and tell them how many beautiful subarrays are there. And the definition of beautiful subarray is like that the size of subarray would be n, and it should be containing a permutation from 1 to n. Okay, so this is the problem asking you to do. So how to solve this problem? So I will tell you the greedy part, how you can solve this problem greedily. Okay, let me tell you the greedy part. So let me erase this question. Hope so the question is clear to you. So let's now discuss the intuition of this problem. So first of all, I will sort this array in the increasing order. Okay, I will sort this array in the increasing order. So what is the sorting part? You can skip this part also. That is equal 1, 1, 2, 3 3 4, that is 3 3 4, and 6 6 7 7, that is 6 6 7 7. So that's how you can so I have sorted the array. Okay, right. So you tell me how many permutation you can perform in the initial array. So the answer is one only. But why? Because because there is a number whose occurrence is only coming one time. Okay. Because there is a number whose occurrence is coming only one time. So the answer in this case would be one only. If you're not buying any if you're not buying any further cards. Okay. So what you have to do greedily, you have to perform operation from well, left to right in the sorting order. And what is the operation? You have to make this that you have to increase this 1 to 2 only. Okay, so because that's how you can solve this problem. You have to increase this 2 at the level, you have to increase this one at the level of 2. Okay, but how? You can utilize this operation, which means you can buy one card from the 7 and increase it clearly. Okay. Okay, so that's the operation which you have to perform. After performing operation, let's suppose you are able to make all these numbers are equal. Okay, let's suppose let me show the code also. What is asking you to do? So okay, so yes, this is the right question. Mm, okay, right. So you have to make the previous element equal to the next element, right? You have to make the previous element equal to the right element. But how you can make this? You have to utilize this operation k. Okay, so I'm utilizing this operation and making this one equal to 2. So that is how my this is equal to 2 only. Now for the next part, you have to utilize this operation and make this 2 equal to 3. Make this 2 equal to 3. You can utilize this operation like 1 is decreased, like you have utilized 1k in here, and your new k is 6. So you can now utilize this 6 and make it equal to 5 and make this 2 equal to 3. Now here it will be 2 3 3 only. Now after performing such number of operation, you will notice that after some number of times your array is becoming equal. Your number of occurrence of array has become equal. But how this will help you? So let's suppose after performing some number of operation in a generalized solution, your total now getting 4 4 4 4 6 6 7 7, which means you are able to make all these numbers equal to 4, which means your main goal is like that. After using this k, your main goal is like that. Using this k, you have to make a prefix equal, prefix of the array equal, right? So let's suppose you are only able to make this prefix equal. Okay, your k is utilized to 0. I'm not taking this example but a general solution. Okay, let's suppose after coming to this position, your k has exhausted and you have no k left. So how many sub you can perform now? You can make now. So total number of 4 ones. So let me tell you how many sub you can perform. How many sub you can make. So a minimum occurrence of any number is now 4. You know that a minimum occurrence of any number is 4 with you. Okay. So let me take a smaller example to tell you. So let's suppose you are having an occurrence of any number like 1, 2, 3, and 3, 4, 4, and make it equal to. Let me repeat it here. Like 1, 1, 2, 3, 3. Okay, and here it is 4. Okay. Now after using k, you are able to make all these occurrence of card equal. Okay, which means in the further operation you will make it 3, 3, 3, 3, and 4. Okay. Okay, which now you know that the minimum occurrence of any number is 3, right? The minimum number of any occurrence is 3. So how you can generate an array from this? You can write it like I'm taking from 1 to n only, which means total number of 3 ones you are having. So 1 2 3 1 2 3 1 2 3. Okay. So total number of um, 1 2 3 4 5. This is the number which I'm taking. 1 2 3 4 5 6 6. 1 2 3 4 5 6. 1 2 3 4 5 6. Now you know that you are only having 3 occurrences of 1. Okay, so how many good subarrays are there in this, or I can say beautiful subarrays in this. So you know this is a beautiful subarray. Yes, it is a permutation of 1 to n. It is a permutation of 1 to n. it is a permutation of 1 to n, which means if you select any subarray of size n, that would be a permutation of size n. If I repeat, if you select any subarray of size n, that is a permutation of size n, and it is also beautiful. Okay, great. So how you will calculate the number of subarrays? That is the minimum occurrence, that is 3. In this case, 3 into n minus n plus 1. Okay, so that's how you can calculate this because 3 into n is simply the size of this subarray. Okay, because 3 is the minimum occurrence, and I'm only repeating. If you notice it here, if you notice it here, I'm only repeating my subarray 3 times. One time, two time, and 3 time. And where is this 3 coming from? From the minimum frequency of any card you are having. So the size of this subarray will be 3 into n, and you have to minus a n because you cannot make an array from this array. Like this is not a this is not a valid array. This is not a valid array. Like this is also not a valid array. Minus n plus 1. So this is the formula which I have come up with. So that's how you can perform the operation. But there is also case in which you are having a leftover case and you can not perform. Let's suppose you are having a case like 3 3 3 3, and here it is 7, and the k which you are having left is 2 only, and the k which you are having to left is 2 only. So in this case you are having k left, and you cannot perform further operation also because you cannot make all these number equal to 7, right? You cannot make all these number equal to 7. So what operation you can perform, and what you can do next, how you can utilize these two at max. So you can simply, let me write the previous array first. Let 1 2 3 4 5, which means a minimum number of 3 times I have to repeat this array. 1 2 3 4 5, 1 2 3 4 5. Okay, right. So that's how you can perform the operation. But how to utilize these two? So tell me where you can utilize these two. Greedily, I would say where you can utilize these two. So I will always try to use this k in the end of the array. Let's suppose I'm using this subarray. What is the missing part in this subarray? Missing part is 1 only. So I will write it 1 here. Now I'm having one more k left. So I will now choose this subarray, which is a number which is not there in this subarray. That is 2. So I will write 2 here. So that's how I can utilize the leftover case if I am having the leftover case left. Okay. So let me tell you the code also. The code is also easy. Okay. So first of all, sort the array in the increasing order and try to make each and every element the ith part of the array. If at any point your value is smaller than k, which means you can make the elements equal. Simply uh, decrease your k and make the maximum value as a of I, because that's what I'm doing here only. I'm making my a of I, changing my a of I at each and every position to the current a of I, that is 3, right? Hopes you are getting this. Hopes you are getting my point. If you are not able to divide the array, then what you will do with the leftover case. So that is also pretty much good question. So let me teach you here only. Let 3 3 3 3 7. So in this question, let's suppose you are having a k of 5. Let me take it 7 only. So your leftover k is 7. Okay, so you cannot make all this number equal to 7 from 7 only. Yes, I cannot make. So how I will utilize this 7? So I will simply calculate at what index I have come up with. So let's suppose I am on the ith index. So I will try to divide this k equally into the I parts. So 1 1 1 1. Okay. So total number of, now the leftover k is with me is 3 only. So I will utilize these 3 in this manner, which I have told you later, that increasing the part later. So how you will construct the array in this? So final configuration would be 4 4 4 4 7, which means total number of 1 2 3 4. Total number of 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, and last one 1 2 3 4 5. Okay. Now total number of 4 times you have written the sequence. And how will you utilize the leftover 3? The leftover 3 you can utilize in this manner. Like try to make the array like this. What is the number which is not coming in this array? That is 1. What is the number which is not coming in this array? That is 2. And at most left, what is the number which is not coming in this array? That is 3. So that's how you can utilize these 3 also. And if you're at any point, you can divide your leftover case in the previous part also, in the previous part only, you have to divide the k in the previous part only, and the leftover k would be divided in this manner. Okay, so hope so the intuition is clear to you. You can see the code also. I will simply first of all trying to make each and every element equal, and if at any point my k is, I'm not able to divide my k in the equal parts, I will simply internally divide that k in the all of the I, increase the maximum number. Right here you can see the logic, and your rest over case will be divided equally. Your k would be left to I k modulus I, because in this case your k, let's suppose your k was 4, your I was 4, then your leftover k would be 7 modulus 4, that is equal to 3. So total of 3 k you are left with, right? So the answer is simply maximum into k, maximum into n plus k. Why I'm adding k? You have seen the logic. That's why I'm adding a k here. You have to see this logic again if you're not understanding this part. So simply subtract the minus n plus 1, because if I'm multiplying maximum into n, there's a stagnant array, which is extra array which is coming all along to handle that part also. And also a later part, if in your array you are now having the numbers greater than maximum, let's suppose this is a 7, which is a which is more than the maximum array, so you can utilize this number also. But how you can utilize this number? Let's suppose this number is 5, so at any point you can add 5 in the array. You can at any point you can add 5 in array and construct the new array like this. Okay, so that's why I'm giving the answer here also. The hope so the problem is clear to you. So let's now discuss the problem D, that is given. So it is the, I think so, the one of the easiest problem which I have solved in this problem set. So how to solve this problem? So in this question, what you are given, let you are given two numbers n and m. Okay, you are given two numbers n and m, right? And there is a condition like that a plus b, your a plus b should be a multiple of b. Let me write it here that your b and gcd of a comma b should be divisible by a plus b. So in this question there's a pretty much good hint, but I can give you like that. Your a should be always be divisible by b. But why? Because it will help in my solution. That's the only reason here. So if your b is divisible, if your a is a multiple of b, then your equation would look like gcd of a comma b divide by, let me take a into x plus b. So if you simplify the solution, your b will be cut down, and your final equation would simply look like x plus 1. So that is what question asking you to do, which means your a should be always be your a should be always be multiple of b, and b can be from 1 to m. B can be, let me repeat it, your b can be from 1 to m, and your a should be multiple of b. So I think so this is the only intuition of this solution. Let me show you the code. The code is also easy. uh, yes, this is the code. Okay, first of all I'm iterating from 1 to m plus 1, 1 to m for b, and simply iterating in the multiple of b's only, because I know here like that if my a is multiple of b, then I can simply find the solution, which means my solution would be more easier to find in that case. So I'm only iterating on those a which are the multiple of b. Okay, and checking the condition. If for a plus b modulus, I think so I've written the question in the wrong manner. Hope so. Yes, I have written the question in the wrong manner. So this is not the condition. The final condition would be x plus 1 divided by GCD of a comma b. So that is the real equation. Okay, you have to only check. You have a plus b modulus b into GCD of a comma b is equal to 0. Then simply increase the count and print the count at the end. But the only catch in the question is like that you have to identify your a should be always be divisible by b, because that is a condition which is which is making this equation, which is by which your this equation is satisfying. Okay, so this is the intuition of all the four problems. If you doubt in any of these four problems, you can comment it down. Until then, stay tuned for the next one. Thank you.